So this is video 4 in a series, and when I was little, I was very fortunate to have a multiplication table uh, kind of game, kind of deal, and it was really useful, and I memorized all these multiplication facts. Um, but as I got older, I started using different strategies, and there's a couple things that you need to know, and in order to do these strategies. And once you know these strategies, then you'll be in really good shape. Um, the factors of a number are the numbers that multiply to that number. And 2 is a prime number, so it's only 1 and 2. And the sum is 0 and 2, because that means 0 plus 2, or 1 plus 1. All right, and the strategy is you're just going to double. So when we multiply a number, we're just doubling it, and so that's not really a strategy. The factors for 3 are 1 and 3 is also prime. The sums are going to be 0 and 3 and 1 and 2. And I don't really have a strategy for 3. But you'll see it doesn't really make too much of a difference. The factors of 4, though, are 1 and 4 and 2 and 2. And because it's 2 and 2, it's a square number. And the sums of 4 are 0 and 4, 1 and 3, and 2 and 2. Now, here's what I want you to notice. There's going to be times when I'm talking about sums that are important, and times when I'm talking about factors. And this time, I'm talking about the factors, because like I said, factors are numbers that multiply to get to 4. Sums add, all right? So since 2 and 2 multiply to 4, my strategy is to double your number twice. And so when you have something like um, 13 times 4, you might not know what that is, but you might know that 13 times 2 is 26. And then you multiply 26 times 2, and you might know that that's really 52. And so instead of having to figure out 13 times 4, you could just do 13 times 2 and then 26 times 2. I'll do one more real quick. 7 times 4. A lot of people struggle with that one. I'm not sure why, but they do. But if you do 7 times 2, you get 14. And then 14 times 2, you get 28. And sure enough, 7 times 4 is 28. So my strategy for multiplying by 4 is to double twice. It's pretty useful, and it's pretty easy. All right, so we're going to move forward here. And I'm going to try to get, I have to say, I'm not terribly impressed with the color palette on this thing, but that's fine. Now, 5 is once again, it's prime, and the sums are 1 and 4, 2 and 3, 0 and 5. But I'm not really going to write the 0 ones anymore. Now, 5 might not seem like a very hard one to do, but I do actually have a strategy for it. And my strategy is this. 5, well, I'm going to multiply by 10 and then divide by 2. Because 10 divided by 2 is 5. So if you had 48 times 5, you might say, oh, I have no idea what 48 times 5 is. But you probably know that 48 times 10 is 480. If you divide 480 by 2, you would get 240. And take a wild guess as to what 48 times 5 is. It is, in fact, 240. I'm going to do another one real quick. Let's say I had 36 times 5. Well, once again, if you multiply that by 10, you'll get 360, but then you have to divide by 2, and you get 180. And so by multiplying by 10 and then dividing by 2, you get the same result as if you had multiplied by 5. Now 6 is 2 and 3, and now I'm going to just kind of write the important ones. 2 and 3, or 1 and 5. So once again, if I'm not sure, I can multiply by 2, then by 3. And so 35 times 6 I don't know what 35 times 6 is, but I do know that 35 times 2 is 70. And I also know that 70 times 3 is 210 because I know that 7 times 3 is 210. So that's actually pretty useful. I'm going to leave this here for now. I'm going to put a little star next to it because I'll get back to it. The strategy for 7, because 7 is prime, so 7 doesn't really help me out too much. But my strategy for 7 is this. I know that 7 is really 2 plus 5. And so this strategy can be applied for the 6 as well. If I had 8 times 7, once again, I'm not really sure what 8 times 7 is, but since I know that 7 is really 2 times 5, or 2 plus 5 rather, I can say, well, what's 8 times 2? That's 16. And what's 8 times 5? That's 40. Well, I know that 40 and 16 is 56, and so that's it. So what I do is I multiply by 2 and 5, and I add. I'll do another one. Let's say I had 12 times 7. Well, 12 times 2 is 24. 12 times 5 is 60. So 60 and 24 is 84. So once again, it's pretty neat. And I want to make one other statement real quick. Now, you're probably not going to learn all of these strategies by watching this video once. I would highly recommend that you write them down and then practice them, and you'll get better. 8 is 2 times 2 times 2. And for here, you might want to say, well, it's also 3 plus 5, so you could use that strategy again. Or you could just double 3 times. So like the same strategy for 2, 4, and 8, or for 2 and 4, you get 8. So if you had like, let's say, I don't even know, 14 times 8, I can do 14 times 2, which is 28. 28 times 2, which is 56. 56 times 2 is 112. And I'm going to show you, you might be saying, well, gosh, you got those answers really quick. And I'm going to show you how I did that in a minute. It's actually the same strategy as I use for these. Actually, I'll just show you right now. What I did was I didn't say 2 times 14. I said 2 times 10, which is 20, and 2 times 4, which is 8. So I got 28. Here I did 2 times 20, which is 40, and 2 times 8, which is 16. And then I said 40 and 16 is 56. 2 times 50 is 100. 2 times 6 is 12, which is 112. The reason why I like doing it this way, as opposed to, once again, our old algorithm, which said, well, 2 times 6 is 12, take the 2, carry the 1, 2 times 5 is 10, plus 1 is 11, is because I don't have 11 and 2. What I have is 112. By doing it this way, I think it gives students a better understanding as to what the numbers actually mean. 2 times 56, 2 times 50 is 100, 2 times 6 is 12. It's 112. All right, 9 is 3 times 3. So if you wanted, you could multiply the number by 3 twice. But I'm going to argue that there's actually a better way of looking at this. 9 is really 10 minus 1. So I multiply by 10 and 1, and then I subtract. So 7 times 9 is the same as 7 times 10 minus, 7 times 1. So 7 times 10 is 70. Take away 7, and you get 63. The way you should know that this is 63 is back in video 1, I talked about compatible numbers, and you know that 3 and 7 make a compatible number. If I were to do 22 times 9, I do 22 times 10 minus 22 times 1, and I get 220 minus 22. once again, be smart about this. 220 minus 22. I'm not going to do, I'm not going to, oh, let me erase this. I'm not going to do 220 minus 22, right? I'm going to do 220 minus 20, which is 200, and then I need to take away 2 more, which is 198. All right, so I hope you're picking up strategies along the way. 10, there is no strategy for 10, just add the 0, but make sure you understand why. It's because you have 10 groups. 11 is 10 plus 1, so it's the same strategy as 9, except I'm going to multiply by 10 and 1, and then I add them. And 12 is actually the same, except I multiply by 10. That's supposed to say multiply down there. Multiply by 10 and 2, and add. And 15 times 12, well, if I did 15 times 10, I'd get 150. If I did 15 times 2, I get 30. So 150 and 30 is 180. And it's really that easy. You do have to practice strategies, and you have to know whether you're using this or you're using this. But take a look. You can use any of these strategies, and what I want you to understand is I'm pulling apart numbers. I'm pulling the numbers apart and not keeping them stagnant. Like this over here, 220 minus 22. Look what I'd have to do in the past. I'd have to say, oh, I need to borrow 1 here. That becomes an 8. Borrow 1 here. That becomes an 11. That becomes a 1. I mean, there is no understand. You don't actually understand any number sense. You don't need to understand any number sense doing that algorithm. Doing 220 minus 22 and then recognizing that I can do 220 minus 20 and getting 200 and then say, oh, but I was supposed to take away 22 and I only took away 20. That makes so much more sense, much better. All right. Anyway, this is supposed to be about multiplication, so I'll stop talking about subtraction here. I hope you enjoyed. Good luck.